Hello and welcome back. After the last video, I actually off camera continued a little bit, where in hindsight I regret doing it because it might have made an interesting video to see how exactly to progress here. And I think maybe I will show some of the prompts that I've been running so far. But I also want to show some of the progress. Let me quickly find the screenshot. So yesterday we finished on the 4v4, 4x4 field. And I let it run. You can see I let it run for a whole hour. It managed to get to iteration 112. The ELO rating, and I hope we had that in the last episode, kept climbing. You can see it got much better than AlphaBeta in terms of ELO rating, but I also think that was mainly just it winning against itself, and you know ELO will keep climbing bit by bit. But you can also see that the win rate versus AlphaBeta just increased, and towards the end we had certain iterations that won all of the 10 games, but not all of them did, and there was quite some fluctuation, and I think maybe games of that size just have this fluctuation. I did play this version and I cannot beat it. So I mean, I played it 5, 6, 7 times. Overall, maybe the game is actually quite complex in terms of understanding what happens when you topple over certain fields, because the AI seems to be very good at anticipating this, right? And then you think, oh, now it made a mistake, but in reality you made a mistake, which is exactly what you would want from your AI. So I ran this. Afterwards, I did actually run a larger network. I just tried to increase the capacity of the network and wanted to see if we can maybe reach that level faster. Unfortunately, I think I didn't take a screenshot, but it didn't lead nowhere. It didn't really get better. It just got as good as the other network. Yeah, I mean, back then Claude recommended me to try increase to a 5x5 field, which is what I did now. Let me quickly pull up. This is the current iteration. The time per iteration now takes a lot longer, so it's more painful to train. You can see it's already running for 5 hours and it's only at iteration 70. And the win rate versus AlphaBeta is not that great. There's a couple of changes I made in this version where it only runs against AlphaBeta every 5 champions, every 5th champion, because otherwise the iteration time just takes way too long. And you know, we could throw more compute at it. It is still better than me, so every time I try playing it I will be the loser. But yeah, I think this training might have actually stalled out. We can see that in the last many iterations it didn't improve. And the ELO rating has changed between the 2 versions. Now the ELO rating is actually relative to AlphaBeta, and I mean, for some reason, no, this one is relative to random, which doesn't make sense. So yeah. I'm not sure if I fully showed off this, but if we play against the best version, it has 5-second thinking time. I think we had this last time. This output policy layer I didn't quite fully explain. What we can actually see here is the percentage of probability it assigns to searching this particular move. So 10% of the time it will actually search this move within the 910 simulations. And then value ahead just says who it thinks will win. And then down here we actually have the individual moves on this board. We can see 3, 4, which is 0, 1, 2, 3, 0, 1, 2, 3. This is the move that it, here, sorry, 4. 0, 1, 2, 3, 4. Yeah, this is the move that it eventually played. And it seems that it visited this 456 time. But it does actually think it will come out. Yeah, maybe here the value head has the wrong I have to double check this. It might be that the value head has the wrong colors here, but I think it is. If the value head is correct, then it would think that it wins most often by playing here. Let's just play maybe 2 or 3 more moves to see this. Okay, so now it starts attacking me. It does this a lot, and you can see 3-2. This is the, yeah. So for example, suddenly the Q value changed, and I interpret this Q value as how much value it gets out of this. So they were at negative before, and now it's slightly positive. So now it thinks it's getting a good deal out of this, which I'm not entirely sure, but you know, I usually make mistakes towards the end. I mean, maybe it's good that it's now controlling these squares. But I mean, I always feel like I can just topple it over. So, yeah, but I mean, I have been in this situation before, and I didn't win. It will still win in the end, because the way you try to then finally kill it, it finds a way so that you topple over your stack, and then it wins half the board. So I wouldn't count it out. Anyway, we have to go over here. The last thing I did is I actually handed it over to a fresh session, because I was running a little bit low on context, and I don't like the compaction from Claude code, so I usually do this manually. Maybe some interesting things is when I say, oh, read something, then it actually reads a skill explained to Henning, so that it knows how to talk to me, because I gave it certain instructions, you know, to keep it short and to use simple language, because I find Claude code sometimes uses a lot of complicated words without saying much. Okay, that was a little bit long intro, but a lot of stuff has happened, but Claude agrees that the training has plateaued now. We didn't see an improvement for a long time, and it actually asks me now what we should improve. More simulations, different hyperparameter changes. I personally think I want Claude to do some research. 10x the model. Yeah, so I will just let Claude do some research. As always, my videos, I will come back when it's done, and then we will plan out what we do next. Okay, I'm back. My main session told me it read my code while in the background it's running some deep research, which may actually kill my my weekly limit and my hourly limit. Yeah, but at the same time I also started a fresh session up here where I told Claude to inspect my code. I still think maybe in the main game code we can improve a lot. I remember for chess engines there's something called bitboards, where you model your chessboard as one 64-bit integer, you know, and depending on where the bits are set, and then you use XORs to compare like moves and calculate everything very efficiently. So I asked it if we can do something similar for my tool, even though that might not be the main time sink. I think optimizing this could help quite a bit in terms of model performance, also for the AlphaBeta search. And I told it to see if we actually implemented only AlphaBeta search, or like, you know, there's improvements called Nega Scout and you know, the hash tables and everything. I hope we have all of this implemented already, but I don't know. So I asked it to create a benchmark and then to start improving this a little bit. At the same time, the main agent already find some things that we can actually improve. Now I guess we wait for deep research to finish. Depending on how my limits move, I will maybe ask it to stop the deep research and just make it a little bit less heavy. Okay, we are back. Both of our agents are doing good work. The deep research, I actually asked it to cancel it, and you can see in like just seconds it blew into 26% of my 5-hour limit. I'm only on the 5x plan, which usually enough for me, so no problem. I asked it to stop this, and it said it found this paper where they exactly handle AlphaZero failing to improve its policy network, and then it has a ranked shortlist of what it would try. I think we will now try isn't the right mental model, then it's fine. You're staffed for learning signal per game. Okay, yeah, this is a good. I mean, we can try Gumbel, PCR, and ownership head. It guarantees a policy improvement even at low simulation counts. This sounds interesting. And then also together with maybe, no Gumbel, this is also what it mentioned here. Okay, yeah, I mean, okay, can you implement all 3 improvements plus anything from your at 5 for tree reuse? Number 5 also sounds good. I think more games per hour makes sense, then it trains faster. I have currently someone editing the board class, so make sure that we don't overlap. Or if you have to change the board class, maybe do it last. If these changes purely live in the AlphaZero subfolder or something, you can implement all of them right now, but wait before you restart the training. For the training that's currently running, you can stop it. Okay, let's do this. Let's go back to this agent. This agent also found some stuff. And you know, this is how usually for me, I will start one agent, and then while one agent works, I start with the next agent, and then before you know it, you have like 10-20 windows open where you try different ideas and do different things. So it reviewed, it built a benchmark, and then here it actually mentioned that toString seems to be 57% of the search time, and undo and move is only 10%, which is surprising, but I like that Claude actually profiled it. The baseline has 4.52 ply, 3 seconds per move, 5 random mid-game positions, committed and reusable harness. The bitboard idea targets the wrong thing. Yeah, it's good. Make undo is already cheap. Yeah, real bottleneck is the hashing, the 8-fold symmetry store. The symmetry store is net negative. Its bookkeeping costs more than the transposition table hits. Ah, okay. We see we actually search deeper without the store, which is very interesting. Where plies actually come from. Oh yeah, you get that from searching fewer nodes, more pruning, not faster nodes. Micro-op buys 1 ply. Okay. The engine is not, it's plain negamax. Yeah, so no null window, no killer history heuristics. Okay. I mean, if you don't know what this means, I'm sorry, I don't want to explain AlphaBeta here because I think I couldn't do it from memory that much. I kind of remember roughly how it works. Recommended plan, drop, shrink the symmetry store. Okay. Zobrist hashing, incremental hash updated, wake undo kills. Oh yeah, this is your packed state idea done right. Oh yeah. Let me do 1 now, then 2. As the foundation, everything else builds on. Rerunning. Okay, do 1 and 2, test, and then 3 plus 4 and test. So I want to do everything. I realize engines like Claude Code, they think in human terms, where they are like, oh, this is so many changes, while in reality, if you say do all of them, it will just implement them in 3 or 4 minutes for you, right? And of course, there will be people who say, oh yeah, but everything is full of bugs or something. If you really, if you write production code, you should probably plan this more. In this particular project, I think it's completely okay to just run and test it. But if you write some production code, of course, you want more planning here. There's the Grill Me skill from Matt Pocock, I think. It's very good. Try it out. And also make sure that your agents write tests for everything. Right here, I'm very lenient on this. I think we can just let it implement it, run it. Maybe later we will just ask Codex to do a review on top of it. Okay, and now I will let these agents run their improvements, and then we come back and I show you what changed. Okay, the first agent is finished, and that's the one who was supposed to make the board more efficient and also to improve AlphaBeta search. And it did run some tests, it seems. So it had some before and after tests, and apparently we improved quite a bit actually. So the baseline had 11,000 nodes per second. We dropped the symmetry and fixed the cutoff. I think it didn't measure this, but then it also added this Zobrist hashing, which is also replacing parts of this toString, I think. And then we made it to 5.2 with 62,000 nodes searched. And then we added the principal variation search and the killer and history moves ordering. And this has something to do with how to order the moves for AlphaBeta search, because I think provably if you search the best possible move first, you will cut off most of the tree, and then you can search a lot deeper because you don't have to search so much. Which made it to 6.2. So before we only searched 4 moves, or ply. I think a ply is a half move. So the engine moves, I move, the engine moves, I move, and then the search is over. And now we actually go 2 deeper, so which is actually a very big advantage. What it changed, it dropped the symmetry TT store. Okay, yeah, maybe okay. It targets the wrong cost. I think maybe one follow-up question I would have to this agent is what's currently the biggest time sink in terms of searching? Is it now really just search? Yeah, okay, wait, this was not very specific. Yeah, maybe we just leave it at this. I think it's detailed enough. In the back, this agent that was implementing all the improvements to Monte Carlo tree search and AlphaZero, actually it implements a lot more stuff now. It was just running tests, doing some actual training. Unit core mechanics are verified, training step end to end, ownership labels populate correctly. Okay, something about multiprocessing. Yeah, and I think it's still running some validation. At the same time, I'm not sure if you have it, but I also have a Codex subscription, but only $20 subscription, and I just sometimes use it to review code. I gave this agent an instruction here to say, I have substantial changes to both the board and AlphaZero implementation, and I asked it to do some bug searching. So now it actually went and read all the code, and yeah, it already found that maybe we forgot to change some of the tests. Now it's doing some web search. What I then usually do is I take the output of this and I paste it back to Claude and let it finalize it. And you can do this 2 or 3 times. There's plugins which automate this. I just do it manually. Usually I look through what it actually says. While we are vibe coding a lot here, I feel like I at least read the output that it gives me, and I do pretend to have a slight understanding of what we are doing still, right? Like I wouldn't say I know the code specifically, but in my experience, even if I go in and I review every line of this code, The newer models are actually quite good at catching this. They write tests, they run things, they verify. We can always see it, right? And then, you know, in the end, at least for me, we will see it in the output. Either the training works or it doesn't. No error metrics written. Looks good. Smoke testing is something that the new Opus model really likes doing. Okay, I will just come back to you once this agent and the code review finishes. Then just quickly gonna show you the code review, then I let the agent implement any comments from the code review, and then after this we can start the next training. Okay, it finished. This one ran some tests. Maybe something interesting to find is, okay, it tested that the new head is training, and interestingly enough, I think it was maybe up here even, it said, oh, somebody else is changing the code. Wait, that's unexpected and important. Some iteration was still running, and then AlphaBeta was modified, and I think even if I told the agent in the beginning that somebody was editing the board, it kind of forgot about it and rediscovered it, and then, you know, it found a stray Python process which was actually Codex running some tests, and then it verified all of this and said, okay, everything is fine. Over here, I actually cleaned the, this is the agent that was implementing the improvements to the board. I now told it to write a handover document because I want to clear the context. In both agents, we're already running close to 200,000 tokens, which is usually when I try to get a new context. And then I just let it write a handover document. I have a skill for this, and then I ask it to read it. And now the Codex review is done. Let me see. I think this might be very small. So Codex, oh, that's the wrong terminal. So now for the next video, I have to improve this a little bit, but we could just use different tabs in iTerm or something. Codex went in, it ran all the tests, it looked through the repository, it actually said, okay, PyTest is running, then it found some compatibility problems, which is good. It now actually searched the web, ran more tests, found that like AlphaBeta is actually, the changes to AlphaBeta produce same results as before. This is quite interesting maybe. It said I compared 1,200 random games against the pre-change board implementation. Check the Zobrist recomputation after every move. And I mean, maybe it just says this. I don't know. It seems to be running some Python processes. But it seems like it ran some simulations and compared the previous implementation to the new one. And then the findings. So it says existing checkpoints cannot load after adding the ownership head. I mean, this is to be expected, and I think it's okay. I wouldn't give this on to an agent, and because, you know, we're not a production system, I don't care about the old runs. Sequential halving selected action is discarded. This is definitely something I should ask the agent if this is relevant and important. It even seems like the web search, it actually tried to find this implementation and said this is not how it's done in this implementation, which is quite good. Pre-existing gate rejection does not restore the previous best network. Okay, this is maybe interesting. Could have been a bug in the previous version. Medium, the Gumbel simulation budget is not honored. Okay. Medium committed test suite is read after API changes. Okay. Medium fresh training run retrains old AlphaBeta benchmark data. Yeah, I think should be fixed. Additional existing issues. Oh yeah, this is probably something that's bad. Pool size, configure, did not find correctness regression. Okay, apart from the first one, I think I would hand all of them off to Claude. So if you don't have access to Codex, you could have just spawned another Opus agent and said, told it to give you a review, I think you would get the same output. This is now the session, well, this is now the session where we just hand it over. I got a review work. And I guess now we let it work for a little bit. In the meantime, I will also run a handover with this agent. I have a handover skill. I think you can find one or make yourself one. It essentially writes the current conversation, summarizes it into a markdown file, and we should give it what the next session will be for. In the next session, we actually want to restart the training with the new model. We do not need to make it backward compatible. We just archive the old runs and accept that they don't load anymore in the current version. We can always go back in Git if we want to. You just need to retain what we did in this session so that we can take this knowledge into analyzing the next training flow. Okay. I will pause the video because, you know, this might take 5-6 minutes now, and then we will start a training run. Maybe I start the run already off camera so that you don't have to watch me wait for the first 2 or 3 iterations to complete. Okay, one small follow-up. So Opus now worked on all of those, added more tests, and then I had Codex review. Why did it scroll up? Review the fixes, and it said it still finds some things that should be fixed. Opponent pool, lower priority issues. I will just copy them one more time, I think, and then we will let Opus do this one more round, because I think now we are actually fixing some edge cases. Depends. I mean, this optimizer rollback, this sounds important. It seems, yeah, so by moving the data between MPS and CPU device, I think we might not copy all the parameters of the optimizer, which might lead to an inconsistent state. This seems important. Evaluation still sometimes plays eliminated Gumbel action. This sounds important too. It will just waste search budget. The opponent pool always includes the current network. This is maybe also something that should be fixed. And then after this one, though, I will ask it also to fix the ELO rating, because last time the ELO rating was compared to the random network or something. I don't think this makes sense. I think the networks all should maybe start with 0 or 1000 ELO or something, and then, you know, as one version plays, all the other versions, they increase and decrease in ELO. Yeah, but I will pause the video because we don't need to wait. I also have I was just sitting here thinking, if it's orange, maybe at that point in time I'm in some sort of queue and Claude is actually not doing anything and it's just waiting for compute to be available. I had that suspicion because, you know, it's saying it's almost done thinking, but I mean, we don't see the thinking, and after that it usually goes very fast. Yeah, actually maybe it's thinking. I don't know. Let's see. Just one quick thing. So while it was now fixing all of these issues that it found, I already started a longer message in voice mode where I said I want to fix this ELO calculation. And, you know, usually I just ramble a little bit and bump some ideas, and then just at the end tell it what I actually want so that it can also come up with its own ideas. I'm not sure if it's particularly good or bad to just ramble like this into the middle of a session where, you know, it was just implementing something else. It does tell me that it will first run the tests and check it, and then it will come back to my ELO question. I mean, if you're patient, maybe you can wait. Maybe we could have actually started a separate session because, you know, we're running into the tokens again, and maybe, you know, this agent's context is not very important to this particular question. This is how it is for now. I will just leave it running. And then hope it fixes the ELO and we can restart the training. Okay, Claude finished, and I always have to smile. I don't know when I did it, but every time Claude wants to explain something to me, it reads the explain to handing skill, which is good, but it also always sounds a little bit like it first needs to look up how to talk to the dummy. On the ELO system, good news, most of what I'm describing exists. Okay, I was talking that, you know, we should have ELO not based on playing versus random, but all the models playing against each other at some point. The misconception, yeah, okay, this is actually not true. I thought actually the ELO is currently running against the random model, which was not very helpful. The actual ratings come from the entire graph. Okay, this is actually, this is what I wanted. So, you know, as we train new versions, the current best version plays against the new version and some of the previous versions. Is this correct? And then over time we will build a ranking on which model won against other models how often. And I think that's already what it is. So in this case, that's fine. The current approach is strictly better for us. No seeding, no order dependence, no drift. If you want to posit, if you just want to change one line, anchor, your each is, the current is strictly better for us. Yeah, okay, then let's leave it. The real gap AlphaBeta, you're right, it doesn't build ELO over time. The strong AB benchmark, right? Separate file. That never enters the result book. Only gets an ELO from few seed matches at startup. Isn't wired up. Fix feed champion versus AlphaBeta. Yo, okay. On fairness of game counts, the champion does play more games than old version. Even counts fine. The only cost is what a version with few games has noisier rating. Yo, okay. Okay, leave the global ELO fit as it is. That sounds exactly like what I wanted. Merge AlphaBeta into the result book sounds good too. And we don't need to re-anchor to 1000. It's fine to start at 0. Okay, sorry. Short interjection. I actually want to get the training started. I will probably do this off camera so the episode doesn't go on forever. Yeah, and then I come back when I have the first one or two iterations trained. So the only thing that I'm gonna do is in the back I already loaded a fresh session with an handover. This one is really just waiting to start the training. Once this agent is done implementing, I will just say, hey, start the training, and then wait for the first 2 or 3 iterations to finish. Hello, I'm back. And as you can see, I let it run for 36 minutes. And I have to say, I'm a little bit disappointed so far in the performance. We can see that we have a lot of rejections. So, you know, especially in the first couple of iterations, I would have assumed that the network constantly gets better. But, you know, we start with random v0, so random initialized network, and version 1 was already rejected. So training a little bit didn't improve our random. Training a little bit more than seems to have improved our random with 100% win rate, and then so on and so forth. I kind of would have hoped it progresses faster, maybe. One thing I'm noting here is we seem to be quite far away from AlphaBeta in terms of our ELO rating, and it doesn't really seem to climb yet, so I'm skeptical. In the background, Claude was monitoring it and said, yeah, it's good that champions are accepted, promotion every 3 iterations. It said, this is all good. I still told it I'm suspicious. I asked how many gate games do we run, because when you see the gate is either 0%, 100% or 50%, and I would expect some values in between, right? Like where's the 65% win rate? Especially if they are random. It's so weird that it wins 100% of the games. Like it should maybe just randomly lose one in between or something. While, you know, in the games versus the random opponent, we see more fine-grained percentages. So I asked it how many gate games we actually run, and it said it should be 20. Oh, oh, this is maybe a bad find. So, you know, match parallel plays 20 games. Look at the seed structure on 900. It just alternates who moves first. The gate games are deterministic. Argmax, no self-play exploration noise, and the opening position is fixed. So all 10 games where the candidate is player 1 are the same. Ouch, that's and that's of course not good. The suspicion is dead on. Here's the mechanism. Apply the fix and restart the run. I would say yes. So I was away for 30 minutes, so I don't mind, but it's of course a little bit of waste. And this is the kind of bugs that you could maybe spot earlier if you spend a little bit more time on reviewing. I will just restart the run here. The video is getting a bit long. I will pause it one more time and maybe come back after another 30 minutes or so. Okay, as you might notice, it's nighttime now. I actually had dinner, let it run. It's now iteration 55. It ran for 3 hours. We can see that ELO is actually stagnating, I think. Yes, we still improve sometimes over the previous model, but honestly, it's not what I expected it to be. Claude also noticed this and said, where was it? Here, the real story flips everything. Where was it? Maybe in here. It offered me some choice and said we can increase the network size, we can run more simulations. Okay, yet another cut. But I had to leave yesterday evening, but I still want to finish this previous video. So I told you that Claude had a couple of ideas on what we can do in order to investigate the ELO rating not rising anymore. I actually had it implement some of these things where, I mean, it didn't add any new features, but it removed some of the previous changes, like the Gumbel method. And we went back to a 4x4 board because it just drains much faster. And even here we can see it's now not converging anymore. We will investigate this in the next video. And yeah, thank you for watching.